here we have a really nice problem where we can try out a lot of our newfound skills. This is a simple problem where you have a system of two pulleys, and we got to figure out exactly how long this belt is to go all the way around these pulleys. Assuming this is 10 units apart from the center of this pulley to that center. This radius is 5 and that radius is 2. This problem has so many nice ideas in it. Let's see where we would start. We would start off by trying to break up the belt into pieces where we can find the length of each one. For example, I could take this piece here where it stops touching the pulley, and I could break that up, put an imaginary mark there. Similar on the bottom, put an imaginary mark there, and I could find this piece somehow. And I could make an imaginary mark here where it stops touching the pulley, and we could find that piece separately. For this one, we could do the following. We know that this radius is 2, and this is 2, and this is 90 degrees, and that's 90, so we could possibly cook up another triangle out of this where we draw straight into that and maybe create a triangle in the center that would help us. Let me highlight the triangle that's going to be the key to solving this whole thing. That right there inside that triangle, that's going to be the key to solving this very nice problem. Let's see what we know about this triangle. Well, let me just say why it's going to be the key, because this shape right here is a rectangle, and so this side would be exactly the same as that side. So that would solve this piece. When by the symmetry, because we can play the same game over here, this side will also be the same as that side, which will also be the same as that side. So by solving this triangle, the pink triangle, I will have solved one of the legs, which will be exactly one of the pieces of the belt, and this piece will be the same as that piece up there from the belt. That will be 2 pieces, and then I'll figure out how to solve this piece and that piece, and I'm counting a total of 4 pieces here. 1, 2, 3, 4 pieces of the belt, and we'll be done. So let's get to it. Talk is cheap. Let me think how many different things we can figure out of the triangle. We know that the radius for this pulley is 5, so this distance, the distance from here to here, that distance has to be 5. But we also know something about this distance. This distance has to be the same as the distance over there, which is 2. That's the radius for that pulley. So this distance is 2, and this whole thing is 5. This is 2, this is 5, this is 2, this is 5. That's got to force this one to be 3, so that they can total up to 5. So we already know something about that triangle, and more than that, we know that this side, which is 10, and that one's across from 90 degrees, so that's the hypotenuse. Let me see if I can just extract that triangle right there and draw a copy of it here, where we can figure out the entire story. This is a right triangle. These are the centers of the pulley that it goes from, this center to that center, and I know that this is 10, and I know that this is 3. From that information, I should be able to figure out a lot of things. For example, let me think. I think I can figure out what this angle is. Theta. Here's what we could do for that angle. We could stand from this reference point of view over here and try to compare things. Say we know from this side, we know the opposite is 3, and we also know the hypotenuse. Opposite and hypotenuse. Across from 90 is the hypotenuse. So you think, which function describes the ratio for opposite to hypotenuse? Well, the sine does. So we could get that sine of that angle theta must be equal to 3 over 10. And this means that we could use a calculator to do the sine inverse function and obtain a good estimate for theta. Let's see if we can go through that. So we would do something like this. Sine inverse, don't die on me now, sine inverse of 0.3. That's about 17.46. That's it. We found already one of the missing pieces. This angle right here is 17.46 degrees. Well, that's nice. That might come in handy later on, but I think we could use Pythagoras to figure out that side as well. You see, because we got two of the sides, we could figure out the third one, or we could use our trig functions now that we've learned them. Why don't we do that just so we can practice our trig functions. Let's call this unknown side, let's call it k. And let's stand on this side again, and let's think about which function describes the ratio that we need. Well, which ratios do we need? We know the cosine, we know the hypotenuse, we want to know the adjacent. Or actually you could do the opposite too. There's many ways to go about this one. I'm just going to use my cosine functions for fun. So I'll say that cosine of 17.46 degrees is equal to k over 10. Okay? So that means that k must be equal to 10 times cosine 17.46. So let me think. I'll go like this. Cosine of 17.46 is equal to whatever times 10. 9.54 approximately. So k is approximately 9.54. Perfect. That's my k right here. Where's the k in the picture? Well, that's this one right here. This is about 9.54. That's excellent because that's the same thing as this one, 9.54. That's the same as that one, 9.54. So I've already got two pieces of the pulley figured out, dominated in the bag. Now what? Well, now I want to figure out the other pieces that I don't know. Let's take a look at this piece right here. Perhaps a good way to look at it is to look at it as having a certain portion of the circle, the circumference of the circle. We don't have the entire circle per se, not even half of it. It's less than half of it, because the belt will not touch the entire half of it. It'll leave the pulley before it gets to the half, because this pulley is much smaller in diameter or in radius than the other one. In fact, let me make a bigger picture here. This is the bigger picture of that pulley, and that pulley, the belt is leaving off at some point. The belt is touching here, and at that point it kind of goes off because it's got to open it up wide so that it could touch the other, go around the other pulley, and the here's the line that's going to the other pulley, and here's a triangle, and here's another copy of the triangle, and this angle right here, that's exactly this angle, 17 degrees. So that's about 17. This is about 17. This is 90, and that's 90. So if you took 360, which is a whole circle, and you subtracted all this, that would give you exactly that angle. Let's go ahead and calculate it. 360 degrees. Then you take away 17.46 minus 17.46 minus 90 minus 90. How much is left over after you do all that? 360 minus 17.46 times 2 minus 90 times 2. I think we have approximately 145 degrees, 0.8. That's the portion of the circle that we have, 145 degrees out of the 360. That might be a good way to look at it so you can figure out what portion of the circumference we have. Let me think about that. We'll do the calculation. Let's use another board here so we can keep the calculation clean. So the whole circle, the circumference is equal to 2 pi r. And this guy happens to have radius which is equal to 2. Therefore the circumference would be 2 pi times 2, which it's 2 times 2 times about 3.14. That gives you about 12.57. Let me see if you can show you that on the screen. Is that a little better? Yeah. But we don't have the whole circle. We only have a portion of it. We have just this portion of it. Precisely 145.08 degrees of it. So that's the portion of the circumference that we'd have. So I could say that this portion would be 145.08 out of 360. That's the number of degrees that we have out of a total of 360, and multiply it by the entire circumference, which is 12.57. That would be the entire circumference, and this is the portion of the circumference that we have. So we multiply them, and that gives you, I'll call this portion, P for portion, and that will give you a total of, let me do it in my head real quickly. I think that's about 5.06. You may want to check that. And that's really great, because we go back up here, and that means that this piece right here, this piece of the belt, that was 5.06. So think about it. We got this one is 9.54. We got this one is 5.06. We got that one is 9.54. The only one that's left to do is this piece over here. So we try to go through through a similar reasoning. Let me think. We try to figure out what angle was that. I think we could figure it out from here, because I know that angle is 17.46. So I'll just go like this: 90 minus 17.46. That's a grand total of 72.46 degrees. So this one is 72.46 degrees. That one's also 72.46 degrees. This will help me figure out what portion of the circle I have. I can make a little diagram here. The portion of the circle that we have, this one is 72, about 72, and about 72. So we have 360, and I take away those. 360, take away 72.46 minus 72.46, and that gives you a grand total of, I'll use my calculator here, 360 minus 72.46 times 2, grand total of 215.08 degrees. That's how big this angle is. It's 215.08 degrees. Now, what good is that? Well, that's going to tell me the proportion of the entire circumference of the circle. So the entire circumference, I'll just use a clean board here to try to keep things clean. Let's study this for a second. Suppose I've got a circle with radius 5, and I want to know the circumference. Total circumference, that would be 2 pi r. That would be 2 pi times 5. That's about 5 times 2 is about 10. 10 times the pi, that's about 1.42 roughly. Okay, that would be the entire circumference, but I don't have the entire circumference. I only have a certain piece of it. I only have 215.08 degrees of it. So for the portion would be 215.08 out of 360. That's the portion of the circumference that we have. I'll multiply it times the entire circumference, which is 31.42, and that should give me a good approximation of the circumference of this, just that piece of the circle. And you can go ahead and multiply that out in your calculator. I'll just do it in my head. I think that's about 18.75, and that's really perfect, because that was the only missing piece here. That was 18.75. Come back over here, and it's duck soup time. This one's going to be easy now. Whoa, I forgot. Oh, it's 18.75 units, whatever they are, inches, feet, whatever. So here we go. I found this piece by finding out what portion of the circle I have, by finding out what these angles were. That piece is 18.75 units. I find out what this piece is, that's 9.54 units. I find out what that piece is, 5.4. I find out what that one is, 9.54. It's all over. The total built length would be equal to 18.75 plus 9.54 plus 5.06 plus 9.54, which is equal to approximately, you can do that in your calculator, I'll just do it in my head, I think it's about 42.87 units. See that? That's why they pay me. Okay, what else do we have to do? I think we just have to shoot. Just a second, I'm thinking. Hold on just 2 seconds. Oh, yeah, we just have to say goodbye. Peace. Watch for a quiz online, do the homework. Do not be afraid. Take your time on these. Enjoy them. These are some nice problems. Okay? And we'll see you guys here next time.